Hello, I think we're live. Okay, so I'm continuing on my quest of making a deep zoom post-mortem debugger. Um, and I don't, if you have been following along, then you would remember that last time we had a very big breakthrough in that we had some the beginnings uh, of realizing that dream. Let me fire this guy back up. Somebody might have shot me a message. Let me see. Okay. Make a new window. It's the chess channel. The chess channel shot me a message. Nice. Okay, so yeah, so this is what we were left with last time. You had the top level of the program. You zoom in, you see the contents of the function, the execution due to the function call, and then you can zoom even more in to get the execution of the sub function call within that function, and so forth and so forth. Yep, that's what makes it a deep zoom user interface, inspired by Google Earth and Benoit Mandelbrot's set and his idea of fractals, um, which is really really fascinating stuff, and that's what inspired me to do this. And I think this is really cool, and I think this is a really cool and helpful way to visualize what happens to a program as it's executing. It can potentially be a really, really good teaching tool, I think. So that's why we're doing this. Let me see. Last time I wrote down some items, some to-dos. So this time I'm going to pick some and work on them. So this is saying FIP1 and FIP0 and FIP1 not rendering in detail mode. This is not totally accurate because I found that if I zoom in, and later on I changed the program. To what? To call FIP7 instead of FIP3, and I found that if I zoom into this level, this FIP5 and FIP4 call, it had the same problem that I saw with FIP0 and FIP1 in the FIP3 version of the program. So this is not isolated to the fact that arguments are 0 and 1, but seems to have something to do with the number of levels we have zoomed in. So, and I'm not sure why that's the case. That's probably the first thing I want to debug. So let's say main is level 1, and then FIP7 is level 2, FIP6 is level 3, and then let's say FIP5 is level 4. It's level 4 that has the problem. Yeah, level 5 for some reason has issues. What are some other things? Maybe display the skip line in a different color. That's less important to me right now. Make it not rewrite the function calls. Oh yeah, currently, yeah, that's also not as important to me. How to remove jiggling. By jiggling, I mean like sometimes as you're zooming in, the text seems to be sort of jiggling. And I think that's a function of the way I'm doing this fit box algorithm and the fact that it's constantly choosing different font sizes. I'm not sure what to do about that exactly, but also not my top concern right now. Oh, and make it work for multiple call expressions on a single line. So currently we assume you're only gonna make a single function call on a single line. Obviously that's not true in general, and we'll need to allow it to work for more, like if we decided to combine these guys on a single line like this, then this thing is gonna completely break. So we'll need to fix that, but right now I want to work on this one. So fix zoom in around level 4, not rendering in detail mode. So that's when around level 4, that's when we went to FIP 5. We try to zoom into FIP 5 and then we get this blank screen. I don't know why. Let's see if we get like a console error or something. Looks like we did get a console error. Seems like, okay. Console error is not at the bottom. The console error is unrelated. It has to do with the fav icon, which I don't care about. Okay. So we'll need to do some investigation on this. Okay. So I guess what I will do. I could try to speculate maybe why this I get a blank screen like this. One way I could speculate is say, did the code to render stuff actually happen or no? I do have a ton of console logs going onto the console right now, so perhaps I'll get rid of the one that was there. Okay, let's do this. It's at moments like this when I wish that this debugger worked for the code I'm working on right now, but alas, that's not the case. What I'm gonna do is have it tell me every time that it has request rendering, so that I sort of get this header of when each re-render occurs. Actually, maybe I shouldn't do it here. Maybe I should do it within the render method instead, which is here. Because I can delete these commented out code at this point, since I've gotten it to work pretty comfortably at this point. Okay, wow, there's a lot of commented out code. Okay. Did I check this in? I don't remember. Okay. And I should be checking in after every session that I stream in general. I'm just reminding myself. But I probably don't always do it. Okay, I'll say render complete here. But the render is gonna call render frame entries. So let's go there. And just print out the fact that rendering frame entries with entries here. I'll probably do it like this, and then I'm going to do a printout in both the consequent clause and the else clause, which is called the alternate clause of the if statement. And I'm going to say, maybe I'll just print out that. Maybe like that, I don't know. And then maybe I'll say, it'd be nice to for recursive functions. It's actually quite nice to for this with these logging information to occur in an indented ways. I think I'm gonna implement that. I'm gonna add a level, which is a number, and then the first one, the first call to this function has 0 in here. So I'm gonna generate an indentation amount, which is a number of white spaces. The amount of the white spaces depends on how many levels deep we are. And then I'll add the indentation at the beginning of each log message, like so. And then when we recursively call ourselves, just here, I will increase the level. And at the initial call of this function, I'll pass in level 0. So that should allow us to have this indented log output, I believe. I hope I'm right about that. Oh, unless I forgot to put... Is it indented? Yeah. It's kind of indented. Yep. Okay. Alright. Maybe one thing that would help is instead of printing console.logging out all of these entries, I am going to cancel the log just how many entries, and also I'll pick out the function name from the first entry, which I believe I do down here. Yeah, okay. Okay. I'll just do that in an ad hoc way here. Then stack 0 dot fun name. So the first. Oh no, it needs to be the last entry, like that. Okay, let's see if that works. Okay, true in. Okay, alright, let's whoa, alright, let's look at these output. I'm gonna put it on the right hand side, and let's read through this log. So this is where the render began. Render calls render frame entries, starting with the main function. Oh, you know what? I'm gonna add one more thing to the log, which is the parameters of the function that was called, and I believe that's not difficult to get either. I'm gonna extract this guy as this frame, stack frame, because stack frame has a parameter. dictionary, which contains all of the key value pairs. I think I'm gonna actually do a little map over the keys, and then for each one I'm going to do like key equals stack frame dot parameters subscript key, and then after this map is done, I'm gonna join it together with that. Put a little parenthesis here. Okay, let's see if that works. No. Stack frames. Where did I say stack frames? Line 131. Here. It's saying it doesn't know what stack parameters doesn't exist on something that of type stack frames. Oh, I meant stack frame singular. Parameters. Did I misspell parameter again? Parameter. Good God, Toby. That's the second time you spelled it like that. And I spelled it right the first time, but wrong the second time. How did I do that? Property keys. Oh, object.keys. Plural. Object.keys. One more thing. I kind of meant to rename this stack frames to stack frame because that's what it ought to be singular here. Okay, and that's all the references to that. Okay, I think that's good. Alright, let's debug. Some small cleanups like that I will do before I forget, but if it's a larger cleanup, I probably will defer it. Maybe write it down in a to-do list or something like that. Or sometimes I don't, because I'm very sloppy. Okay, so I think that's good because, wait, that shouldn't be the literal key there. My logging is wrong. It should be the variable key. Okay, let me just check on the quality of the stream. It is looking good, I think. Okay, quality of stream seems to be good. I'll check the YouTube window. It says excellent condition. Oh, or not. Well, you know, we'll do the best we can with what we have. Okay. So this looks better. So this shows us the stack frame, and it's in a nested configuration, and that's really nice actually. So and this trick with the levels that I did is this one, and then you use this level number to generate an amount of indentation for your log messages. I highly recommend doing this if you're trying to debug recursive functions. Very, very helpful. Yeah, it takes a little bit of setup like this. I did it a very, very manual way, but yeah, and I don't have like a nicer utility. Oh, actually, at one point I did make a slightly nicer utility that sort of does this. but even I don't remember to use that utility, and that utility takes a little bit of setup as well, so whatever. Okay, so render frame entries, there are 239 sort of states or snapshots for the execution of the main function, and within that there were 236 that were within the fib function called with parameter n equal to 7. And then within that, there were 143 of them which were for the fib function called with parameter equal to 6. Oh, what did I just do? I just wanted to increase the font size of the console here. Did that work? Yes, that worked. No, that's too big. Alright, I think this is a good size. So yeah, so in the console here, I might take a screenshot of this actually, because this looks kind of crazy, and maybe it's a good screenshot to use for the thumbnail. Okay. Let's see. So far, these things are okay. Yeah, this guy. Yep. Okay. So if my area ratio is greater than 0.5, then I'm gonna recurse. But if it isn't, then I'm not. So it did not recurse for this one. It did not recurse for this one. But did recurse for this one. The fact that it did recurse is the only way it would have gotten to these child function calls. I guess the thing that I'm really interested is when you zoom in to fib5, what happens? Why do I have this blank screen right now? Let me see. So for fib5, actually, there is this fib equal 5, this fib equal 4. Both of them are, but for this fib equal 5, the area ratio is actually greater. Let me see. Zoom back out. Okay. Zoom in a little bit. Alright. So for fib equal 5, I think this one, my area ratio is greater than or equal to 0.5, which tells us to recurse for fib n equal 4 and fib n equal 3. I guess my question is, why didn't that show up? And also there's supposed to be the code lines that show up. So it went in here clearly based on the logging anyway. It should also have generated these boxes, these code boxes, before doing this recursion call here. So it should have, and then it does this fit box thing. The fit box should have drawn the code. So maybe I need to inspect that. Alright. I'm a little worried about printing this out, but you know, gotta do what you gotta do. I feel like the computers get a little, or this program is gonna get a little slow once I do this. I'm gonna clear out the console and then do that. Okay, now we are, let's see, let's try to make sense of this output. Okay, we're rendering and the main function, and then area is greater than 5, and then fib n equals 7, area ratio greater than 0.5, fib n equals 6 is also greater or equal to 0.5. These were not greater or equal to 0.5. The fib n equal 5 greater or equal to 0.5. So now we're doing this stuff. But before the recursion though, we should have created this box with the code inside of us. Yeah, they are there. It could be the fit box algorithm screwed up. Yes. It could totally be that the fit box algorithm screwed up and is not able to render this or lay out these things correctly for some reason. And to be able to tell that, we actually need to print more stuff out. So let's do that. Okay. Okay. Whoa. Okay. Wait a minute. This. Oh, dang. I meant to print out the B box map. Although I suppose my box is helpful too. That's a very, very large width. Wonder whether it has to do with quantization errors. Like the numbers are getting too big, maybe? That's possible. I dealt with this when I was creating the Mandelbrot set, actually. You zoom in, zoom in, zoom in, and eventually you have quantization errors, and the image gets pixelated. This is kind of early for this to be happening, though. Let me see. So the one... let's see, my box. So it should be rendering the stuff within this box. Seems like it's doing that faithfully. It's starting the text at the sort of top left of this box, which is specified by this x and this y, so it's negative 7,684, and then y is 36,491, and that is starting where that x is and that y is. So I don't really understand still what the problem is at this point. I don't see a problem with the layout algorithm. could do. This fitbox algorithm, let me look at it to see if I can recognize any clues here. So we get this sort of while loop which does this binary search thing. After the binary search, it takes the box map that was generated by this layout algorithm in the last round and then renders it. What's the problem? It seems like I'm not at the point where I'm not yet zoomed far enough until the point where all I see is in this box, is what it's in the box, and yet the screen completely blanked. I wonder why that is. I mean, this clear rect could have contributed to something blanking, I suppose. One idea I have is maybe if I remove the clear rec. It might be. Oh, another idea I have is. Oh, yeah. I have an idea now. I can record the viewport, the current viewport, or the problematic viewport, like here. Whatever the viewport is at this moment. Is it a global variable? If it's not a global variable, that's cool. I can make it available somewhere. I have a viewport. Yeah, that's the viewport variable. I can display these values somewhere, maybe in the DOM. Log. Let's say I'm gonna create a pre-tag, which I'm using as a log, and then whenever viewport updates, I'm updating the log to tell you what the top left and zoom is. Where does it change the zoom now? Oh, this is mouse move. Okay. So I'll call something like update log. Maybe update log should just be called within request render, maybe, or just within even within render, maybe. I'll do it within render. I'll call update log. And then what update log does is it'll just take the viewport left, just display the viewport basically. That's the display message, and I'll say log.textContent equal to that display message. Okay, so I should see it down here somewhere under the canvas, possibly. I did something wrong. Oh, I thought I would see it. I don't. I didn't add it to the body of the document. So let's go do that. Still don't see it. Why is it way down there? Oh, I see. Because we did this translate thing, and that's weird. Okay, I think maybe give this guy a absolute position, and then say it's bottom one. That works. So style position absolute style bottom equals 1 pixel. That should allow us to see it, I think. Yep, okay. We see the position of the viewport now, and we're going to zoom in. And the whole reason we're doing this is so that we can sort of initialize the application at that zoom level instead of having to manually zoom into it. And once we're in at that zoom level, perhaps we could change things around, such as remove the remove the clear Rex. Yeah, that's my plan. Okay, so that's the left. Oh gosh, what's going on? Okay, all right. I'm gonna try to copy out, or no, don't do it. Oh, oh, my mouse events are kind of I'm not able to copy basically. Okay, just read it off. 899.2. So the left is 899.2. I guess I'll comment this out for now. Top is 154.122, 154.122, and then zoom is 137.39. So if I do this, then initially I should see this blank screen, which I did. Good. Now, because I suspect a clear rec somewhere is making it that so that we don't see any output, I'm gonna remove the clear rec line, and that didn't fix anything at all. I'm also gonna remove the clear rec over here just in case, but I don't think that. Okay, so removing the clear recs didn't sort of uncover anything at all. Very interesting. So, alright. We did call the fitbox function at some point. Okay. I need another idea. Let me look at the log output one more time. So if I okay, so we're rendering here, and then we're rendering frame entries, and then rendering frame entries for fit n equals 5 here. This is the fit n equals 5 where my area ratio is greater than 0.5, and then we recurse in here. And then these are the text boxes we want to render. Yeah. And then the B box map here, it gives it a screen coordinate, a bounding box for each box. I could consult the, let me think. Okay, I'm gonna remove this line of console.log, and maybe I look into the fitbox algorithm, in particular the render algorithm, because that's the one that's responsible for actually rendering stuff. There's a stroke box, and there's a fill text. There is something that sets the font size. We could look at what the font size is when we're calling the render. Maybe this font size is too small, but I kind of don't see that causing problems though. Because if the font size is too small, it doesn't show up. That's not a big deal. Yeah, let's go ahead and log each of these fill text calls. Maybe that will give me an idea. I'm gonna print out both of the arguments to fill text in the console. Let's see what happens. Let's look at the position where we're still seeing stuff. I'm going to zoom out. That's here. Just before we went into this blank screen. I think that's pretty close. Now we're blank. I'll come back just a little bit. So that's not blank anymore. Okay. We're doing fill text. There's some positive coordinates right now. I guess, these coordinates are actually on-screen coordinates. Yes, they are. Because, yeah, at this point, the coordinates should already be on-screen coordinates because the translation from in-world to out-of-world, that was done, or I should say the translation from world coordinates to screen coordinate. So let's see, where does that happen? From a box, translate a box to from world coordinates to screen coordinates. That's here. That was done in here at the very top of the render method. So if we pass the coordinates to the render frame entries in terms of screen coordinates, everything, all of these calculations are done in terms of screen coordinates. So that kind of makes sense because now if we're gonna ask it to render this text, this is not on screen. This is a very large negative number. It's not gonna show up. Okay, I guess, okay. That sounds like a good reason. I'm gonna confirm that. So the hypothesis I have is, which seems to be confirmed, is that all of this text that are being drawn on the screen using this fill text method call not showing up because it's being done on these negative coordinates, which are not gonna show up on the screen. I was kind of suspecting that at the beginning, but I didn't say anything because I thought these were world coordinates, but no, in fact, they're screen coordinates. And the screen is the coordinates of my screen is 1200 by 1200. That's the coordinate of my screen. So 1200 across and 1200 down. So it's 1200 here. So at the point at which the text is still showing up, it's here. So let's see. Okay, so at this point when we're seeing stuff show up, we have these coordinates. We're drawing these text well within well, at least within a reasonable range where it can be seen. Some of the text is out of range, but like this is 11, which is the line number. The line number is all the way over. Line number is all the way over there. But for a line like def, fib, and we drawn that at negative 135, 849. It might be this one, so maybe like it's over there. Negative 135 and 849 is this one. So this one is showing up. Okay. But when you zoom in more, let's see. Then all of these coordinates are off screen. This is a very, very large negative number. Very, very, very large negative numbers. So I guess the problem is that in the first place is that we have a very, very, very large negative number in the on-screen box that we're trying to draw into. So I think probably I can eliminate the problem, let me remove some of these console.logs. I don't think the logic is problematic. It's probably not due to the logic in the recursive render stack frame method. So I'm going to decrease the amount of output here. So, and let me go to the fitbox algorithm. Okay, I'm going to remove this console log. And then in the render function, I want to print out, no, not in the render function. I mean, not this render function, in this render function. I'm going to print out the box that was calculated in canvas coordinate. Here. And we shall see what happens. Yeah. Okay. Yeah. Okay. So, whew, basically, wow. Okay. Both x and y are very, very large negative numbers. But then the width and height are both very, very large numbers as well. So, I mean, if you have this canvas, if you have a coordinate, let's say this coordinate was negative, well, x is negative 1, 2, 3, 5, 4, 1, and y was negative 2, 1, 1, 4, 7. And the width was 1, 6, 4, 8, 6, 7. Width is 1, 6, 4, 8, 6, 7. Then if you add this number to this number, you would get 6, 4, 8, 6. It's approximately 41,000. Okay, this is approximately 41,000 ish, and then well, okay. Let me trying to figure out this bounding box, and then this height is that. No, wait, I messed up. No, width and height are about the same. Okay. That's also the height. So you add that guy to that guy, then the height is, I said this is 41K-ish. But then the height is, you add this guy to this guy, which is 1400, 3000 ish. So, which means there is still part of it that is on screen. The only visible part within this is a very, very small part, I think, because these numbers are so humongous. Like 400, 1200 by 1200 within these very, very large numbers. And like 164867, 164867 is 0.007. So that's less than 1%. So maybe it is being rendered, but it's just being rendered as a very small dot because the actual canvas is less than 1% of the size of the actual canvas. And we're drawing. Wait, no. Oh yeah. So just like we're drawing within this big old canvas, which has a width and height of 160K, 160K, but canvas is this tiny dot here, which is, 120 by 120. It's this area of this guy is less than 1% of the area of the outer box. So, and we're rendering within this outer box. We're saying like, hey, write this code here, like this, and then we have lines of code here, but the part we get to see is just this tiny box. So it just happens that whatever is in this tiny box doesn't meet any of this text here, so it happens to be blank, which is very probable because most of the space is probably blank. The amount of space that is black and has text on it is probably minimal. So I think that's why. However, that brings us to another question: is it correct for it to have this very, very enormous dimension? So let's just track the growth. Oopsies, the growth of this this box, and we'll track the growth of this box as we're zooming in or zooming out. And then let's turn off the other logging that we have. Yeah, let's turn off this logging. Turn off this logging. That. Okay, that probably is good. Okay, so I'm gonna reduce the zoom level. Okay, so at this point, At this point, we already have a very large sized canvas. It might be a quantization issue, I think. Yeah, I think at some point the zooming is so far down that we don't know where the text is anymore. How can we solve this? One idea I have is start with a smaller height and width initially in world coordinates perhaps. Um, but that seems like just delaying the real problem, because eventually this height and width is gonna be large still. And also, I kind of thinking, I'm not 100% sure about my hypothesis, actually. I guess at this point, the height and width is 112974, 112974, and then it's actually 1% of the canvas is 1% of that size at this point already. So the actual actually, let me look at my File Explorer project. Try to get some insight from that other project, which was my first experience building a deep zoom interface. So let me bring up the code. Okay. So in here, I guess we could do the same kind of debugging technique where request render. Let's look for the render function. This code has more or less the same structure as my debugger, because the debugger was modeled after this one. Oh, but in this case it's a little different because the conversion to world coordinate is done in a nested way. Interesting. I wonder whether that makes a difference here. Maybe it does. It might be hard to. So this conversion to canvas coordinate is done here, but it's done within this function rather than done in the top level function and then passed in. So that means each recursive call, which happens here, it has to do the conversion itself. And then the calculation in here is actually done with in terms of world coordinates. And let me see if I run this demo. I've never seen quantization issues happen. In the file explorer. Oh, the file explorer needs an API to be running. Let me go do that. Is it running? Oh, it is. Okay. Okay, so, or no. No, it's not running yet. Hello? Now it's running. Oh my god, it took long enough to. Is the stream still going okay? Because it's 10 frames per sec, 16 frames per sec. So no, the stream is not going okay, but whatever. Okay, so let me start this. Okay, so zoom in. Ooh, Jesus. Okay, I'm gonna, I guess, zoom out a little bit. This is the playground, and wow, I actually have a lot of, these are all my side projects. I have a project called Poop. How did that happen? I'm actually worried about going in there right now. There's a play.js. What's in it? I don't see anything in there. Okay. There's also a thing called Kim. There's an ASM. Let's go into the ASM directory. At one point I was learning assembly language programming. No, but it might not have anything that goes even deeper. So maybe I should go to a project that's like an Angular or Rails maybe, because Rails has a lot of file structures. Go to vendor maybe. There's nothing in render. I don't know. Where should I go? Flask? Flexbox? Learn React? Sure. React with nothing. React with classes. Oh, okay. I have a feeling that's not what I'm actually looking for. I'm looking for, oh, probably this ng play one. Yeah. If it has node modules in it. No, it doesn't. How about this one? Does it have no modules? Here, Tour of Heroes. Does Tour of Heroes have node modules? Oh, I made a script that removed all my no module folders. Ouch. Yeah, I remember that now. Okay. That's hilarious, actually. I made it hard for myself inadvertently. I guess what I'm trying to get at is I want to zoom in really, really far. It could be possible that I just never encountered this issue with the File Explorer because I haven't had to zoom in that deep yet. I don't know. Let me stop this. One possibility is that, well, I don't know, there's some quantization issues with first converting to canvas coordinate on the outside and then within it converting to not converting but just working with a viewport that's that enormous. Maybe we should instead not do the conversion here. Maybe pass in the box before converting, and then why am I stroking here? I'm getting rid of this one. So maybe I should not do this box world to canvas in here, but instead of doing that, I should do it within render frame entries. And then now, so this is box. And then I'm gonna do a conversion to canvas box. Box world to canvas. And then I should use, actually I'm gonna call it my box so I don't have to rename all these variables. So because it was using my box in all the places. Like ClearRec should definitely be based on my box. However, for the call, the recursive call, which is all the way down here, maybe I should not use. Maybe I should use the original box here. And then, yeah, you use the have fitbox work in terms of the original world coordinate system. Although there could be quantization issue there too, but I don't know. As in the number gets so small, the numbers will need to be so small and precise by the time it gets like, let me show you what I mean. So if I'm saying that I want this, I guess that's a very interesting with the building deep zoom user interfaces in general, probably. And I'm sure there's a way in computer science to cope with this, but I haven't really researched the literature. Yeah, I think I'll need to figure out how to fix this at some point. Like research the best way of dealing with this at some point. But the point is, if I'm saying my canvas coordinate is 1200 by 1200, I'm gonna render some stuff in it. But let's say my viewport, I'm zooming in so far that my viewport is very, very small. But within the very, very small viewport, I'm gonna have even more details that look like within, like my viewport is so small that it's gonna be like that. Okay, sorry. Let's say this is the world coordinate. This is the world coordinate, not the canvas coordinate. Like after we zoom in many times, our viewport is going to be like this, which means the canvas is actually looking at just that small slice of the world, and if we blow it up, we still have a lot of detail within that very small dot to be rendered, such as maybe it's another call to the fib function, and then it has text and so forth and so forth. But because this dot can get very, very small, we could have numeric precision issues, as in to represent this bounding box, we're going to have decimal places. of many points, and I think sort of the double floating point number precision sort of breaks down after a certain point. And so I'm worried about that happening, but I'm gonna try this technique where with the fitbox algorithm, I'm gonna do it on the world coordinate instead of the canvas coordinate, and then later on converting that world coordinate to canvas coordinate in each recursive call. See if that fixes this issue for us. Let's see. What is that thing? My son is knocking on the door. Let me take a look. Hey, what's up? I'm doing a stream. Whoa, that looks beautiful, Cody. Wow, that's amazing. You drew this today? Yeah. Let me show the people on the stream. Hey, my son Linus made this picture. I think that's amazing. So colorful. It's France 2006. Yes, they were the World Cup winners. That ball looks super good. Look.
I traced it.
Oh, you traced it. I see. That French flag looks amazing. Very colorful. And the sky and that grass look great. And the net looks very detailed. Good job. Okay, let me see if this works. There's massive bugs right now. Massive bugs. I think it's because okay. I'm going to revert the initial viewport to what it was before. And then maybe work from there. There's definitely massive bugs after I made that change. Okay, so this is main. Zoom in. Whoa. Whoa. Okay. What? When I'm dragging, I'm not actually changing the position of this guy. Why is that? That's weird. Oh, this code. Oh, I see. I think I see. The fitbox. Oh, the fitbox also renders. And also, there's another call to fitbox here. This one was this fitbox call was based on canvas coordinates. But then this one is based on the world coordinates. So they're done differently. But when you do it here based on world coordinates, it also actually renders it. And I actually don't want to render it if I'm gonna do it like this. I see. So that explains why there's a sticks there, even though I pan this around. But nevertheless, I might be able to test out whether the quantization issue is fixed. And I think the answer to that question is no, it's not fixed. No, it's definitely not fixed. Wow, okay. I didn't anticipate this problem to be this hard. And this is also interesting, like what the heck is going on here? Okay. Let me revert this change then. And I'm gonna try again. I'm gonna scrap my theory. And I'm gonna try to think again about what might have gone wrong. Wait. Huh. Actually, I spoke too soon. I wanna try to debug. I'm gonna redo, which is command Y. Actually, I wanna redo. I wanna try to debug it in this scheme, even though it's really out of whack. Okay, let me try this. Because I actually, let me have it all the way zoomed in. Because I can print out the boxes as using render frame entries. I can print out the boxes that are currently being drawn too in the sub calls, I believe. So I'm gonna uncomment this console.log, and then I'm also gonna print out the box as well as my box. My box is the one that's in canvas coordinates, and box is the one that's in the box is the one that's in world coordinates. So this is saying, let me read this output again. So for FIP5, this is a little hard to read actually. Render, we do a main, and then we do FIP n equals 7. FIP n, I think I want to print the lines that tell you which branch it took here, because that was helpful. Okay. Alright, so the world coordinate is that, my box is that, and then for FIP n equals 7, the box is quite a bit smaller, and then for FIP equals n equals 6, the box, the width and height is 15 pixels by 90 pixels, and then for FIP n equals 5, the height is only 2 pixels, and the width is 12 pixels, and then for height and width is 15 and 90 here for this n equals 5. Is that right? And then this is 2 and 12 for n equals 4. Right. And then sort of the box we got as a result. For n equal 4 is when you translate it to world coordinates is x is -4, y is 2000. This is canvas coordinates, so y of 2000 would push it out of sight, I believe. These are at least smaller numbers that sort of makes more sense to me. So intuitively, I feel like this scheme, even though I have to debug it more, can probably is easier for me to think about it and debug it, because I don't know why there's a little box here right now. Okay. Alright, I think I'm gonna take a break because that was kind of a grueling session. And I might come back to it today later on. So